most of you would have worked with LLMs. You would have either used the likes of ChatGPT or Claude to go and ask a question, or if you're a developer, you're using the copilots that are helping you write better code. Now, what we are going to talk about in this video is a very popular concept called Retrieval Augmented Generation. And if you have been working with LLMs or building applications on top of LLMs, it's highly likely that you have stumbled upon this. We'll want to understand this in a more structured way. We need to understand why RAG is good and what are the scenarios in which we want to use RAG, and also look at other elements like prompts, fine-tuning, training from scratch, etc. This will not be a deep dive video, however it will be a overview and introduction to Retrieval Augmented Generation. Let's get started. So RAG is an architectural approach that improves the efficiency of LLM applications by leveraging custom data. And this custom data is really the key. LLMs are almost always trained on known popular data set, public data set, up to a certain point in time. So they would have been trained in 2021, 2022, 2023, but there is usually a time at which they are trained, and post that training period or post the data, their knowledge of the information or their knowledge of events of the world or data is non-existent. In addition, they would also not understand your organizational context, and that's the primary challenge if you want to use LLMs in an enterprise. So the problem one is LLMs do not know your data. Second, LLM's application must leverage custom data, because if you are, let's say, using LLM to write your marketing copy, you would want it to be aware of your brand persona, you would want it to be aware of your products, you will want to give it a narrative, you'll want it to give it a template of sorts, right? So it's significantly important that LLMs know about your data and leverage your data. And solution now is RAG is almost an industry standard. Everybody uses it in most enterprises. While this article is from Databricks, I just happen to like the article. If you search, what is RAG, you would literally get every single cloud provider like AWS, NVIDIA, IBM, Databricks, DataCamp, tons, everywhere you would find a definition of RAG. The concept would be pretty much the same. We could look at different diagrams, etc. But the idea is augmenting data that is your enterprise or your use case or your system specific to LLMs. Now, how do we do that and where do we put it? You could use it to build Q&A chatbots, you can use it to augment searches, you could make it to do research, you could make a knowledge engine, you could add it to documents, where people are aware of, the LLM is aware of what's running in the document and it's giving you recommendations. So even I would think kind of coding assistants where they look at your code base and make recommendations, gain an understanding, it would be some form of RAG. It could be fine-tuned, or I wouldn't say fine-tune, instruction-tuned models, but RAG would be really deeply integrated. There are no alternatives right now in this space. I would want to call that out. If you want to put your common knowledge base, if you want to put your enterprise data, if you want to use your custom data, RAG is the only approach to go about. Alright, quick shameless plug. I'm trying to reach 3,000 subscribers in the next 2 months. If you can contribute to the subscribers and if you like my content, please pump up. I talk about LLMs, I talk about technology, software architecture. Let's come back to the content. What are the benefits of RAG? The most common and immediate benefit is it gives you updated and accurate information. It reduces hallucination, it reduces inaccurate response, it makes the domain relevance up high, and it's a really cost effective, simple to build approach. You have a lot of tools that can build simple RAG using drag and drop tools, and if you want to get into more complexity, there's definitely applications that can help you. There's frameworks like LangChain, Llama Index that can help you build deep RAG systems, which we will take a look at in the next few videos. Alright, so there's always this question that when should I use RAG and when should I use fine-tune, when should I use prompt? And the reason why I like this architecture or article more so is because of this table. Now these techniques are not mutually exclusive, they are highly likely to be combined. So for instance, prompt engineering will almost always be there, RAG will always be there, fine tuning might or might not be required, and if even if it is required, it's highly likely that you will do the up top elements. All right, so let's look at all of them. So prompt engineering is crafting specialized prompts, really quick, do it on the fly. There's no data requirements, it's really cost effective, there's no training required, and absolutely it would give you a good enough number of results if you learn to how to control your prompts. The second is RAG, as we are talking about it. So you combine LLMs with external knowledge base. You can have dynamic data sets, external knowledge bases, and there are some data requirements. You will need to do indexing, you'll need to have a vector database and things like that. However, the advantage is your data is aware, your model is now aware of the data. I wouldn't say the model is aware, the system is aware of the data. System is a combination of the LLM and the setup around RAG, and you get a really high degree of accuracy in it. It increases prompt length because you are passing more information and inferencing computation, so this is slightly costlier than prompting but gives you much better results than raw prompting. The third is fine tuning. So essentially, if you are adapting a pre-trained LLM and applying some domain information, doing transfer learning, that kind of exercise is what is fine tuning. So you basically take the top few layers of the model, not necessarily top few, couple of layers of the model, and you can pass domain specific instructions, domain specific data. You will need labeled data for it, but what this gives you is the ability to have a really granular control on the LLM itself and high degree of specialization, which cannot be achieved by the above applications. What you do need is a lot of detailed instruction samples and data for it to be able to work. And finally, pre-training, right? Training an LLM from scratch. Can you train an LLM from scratch? Absolutely yes. An LLM is essentially a transformer model, encoder decoder model, so you would be able to train it from scratch. Now, how good you get it and how big of an LLM or how many billions of parameters or millions of parameters you end up cooking it there depends on how deep your pockets run. So basically what you'll need is insanely high computation, large amount of money, and large amount of data to be able to train it. So this is really resource intensive, and this is why you have very few players in the market. It's like a winner takes it all conversation. There's OpenAI, there's Anthropic, and there's a couple of more providers in this space. All right, so that's what is RAG, and those are the key areas that we can focus on from an LLM perspective. So talking about the complexity and computational intensiveness, prompt engineering is the lowest, and pre-training or building an LLM from scratch would be highest. This is a simple architecture. Let's take a look at it. Now, as you would have understood, what this requires is it requires raw data, and the raw files essentially, let me see if I can make this even bigger. Can I zoom this in? Yeah. All right. Yeah, makes sense now. All right. Yeah. So the data prep, essentially you need your context data. Whatever it is, you need to chunk it, you'll need to vectorize it, put it in some form of an embedding and store it somewhere. In Databricks case, you could store it in Delta Lake. There's different sorts of technology available. There's no specific reason to stick to this. However, Databricks is a great recommendation if you want to build RAG architectures. The next is you would want to index the relevant data, and in indexing you could have embedding models where again Databricks can come in. So different foundation models, and foundation models are the core LLMs, will enable you different kind of indexing options, different kind of embeddings, and you can use these foundation models to build embeddings on top of your data. You can also bring your external embeddings, you can bring your external vectors to this conversation, and finally you would essentially query your vector index. And then you have an information retrieval step where you are relatively chunking the data, and finally LLM inferencing happen where there's a chatbot and an end model endpoint. So you ask a question to the UI, it goes back and does its magic, etc. All right, so that's essentially what a RAG is. Let me go and let's talk a few components. So vector databases are required, not all, but most of them would require a vector database. You would need some sort of a deployment or model serving, which is the LLM deployment. If you're using pre-existing LLMs like OpenAI Key, you probably don't need all of these steps. All right, Now, talking of frameworks, LangChain is a really interesting framework in this space, and I'll just want to end this conversation with showing a simple diagram of a LangChain RAG if a architecture diagram of sorts exists. I don't see it, however. Okay, yeah, here it is. Now, I don't know if this is specific to LangChain, but yeah. So if you see in the diagram, right, what is being talked about is a massive data set on the left hand side. There's a pre-trained LLM, could be an API key from an OpenAI or any other LLM that you want to use, and the query is going to it. What's happening is the user is making a query, which is a question, is giving it into a retrieval model. There's a knowledge base relevant document search kind of happening. This is where the vector database embeddings, all of that conversation happen. So the retrieval model has the query, and the plus is the relevant doc information and passes that in a prompt to the pre-trained LLM, and on top of that you pretty much get the response. So that's pretty much what a RAG architecture is. Now, a lot of customers in this article are using Databricks. On Databricks customers, again, this has nothing to do with Databricks, but these are really interesting videos, and it would be nice to watch if you want to spend some time in understanding how different enterprises are implementing and solving their use cases using RAG. Alright, so with that, this video is an end. If you have liked the conversation, give a thumbs up, put in comment what do you want to see next. Till next video, bye bye.